Um, so thanks for inviting me. So I'm Hugh. I'm a PhD candidate from the University of Illinois at Urbana-Champaign. And during the summers, I'm also working with the Argonne National Lab on the project called APPFL. We select the Argonne Privacy Preserving Federated Learning. And it turns out to be using funcX can help us to improve our framework a lot. And today I'm excited to share with you what we have done so far. So basically, we have a team composed of multidisciplinary teams from different institutions, from Argonne National Lab, Harvard, University of Chicago, and UIUC. So this is raw team, and I want to share with you what we have done. So for the key motivations and objectives of our framework is that we want to tackle the problem of data shift in machine learning. It's basically like the situation when you train a models on one data set, and when you're moving that models to a different data set, the performance likely to be dropped significantly. So how can we learn from the data effectively? This is from one of our questions. And secondly, we want to tackle the problem of the privacy concerns with biomedicine data. They are very rich resources of data set, but there are several concerns related to the privacy. So how can we take the useful knowledge out of those data sets without violating any kind of privacy concerns? So that is the reason why we developed a system called APPFL, which is like the Argonne privacy preserving for federated learning tasks. And we implement different differential privacy algorithm, federated learning algorithm, and we want to use all of this framework to work on some kind of biomedical data set, and this should come from multiple organizations. So just to give you a brief overview of federated learning, it's basically a process that involves different sites. They can have their own data sets, their own computing machines. We have a server in the middle, and we want to do the learning, training models using the data set from different sites. And the constraint here is that the data should never leave the site that it is stored. So we only communicate and take the information we need out of the data without transferring the data out of the institutions. So in this scenario, how can we communicate from the server, let's say, to different sites? And it turns out to be funcX. funcX is very useful tools for us to do this, implement the communication and doing the training remotely. So basically for the federated learning, there are several things that involve. The first one is the research teams. When we only have approved teams of researchers from different institutions, how can they collaborate with the others? We have the problem of data management and computing resources management. So you can imagine that each site, they have their own data set, own computing machine. So how can you collaborate? How can you execute the jobs? How can you do the jobs effectively? So for the first one, in order to collaborate the installation between different researchers, we use a global service for identification. And APPFL can help you to handle the rest when we have a system that can communicate and do the training on the local machines and aggregate the information. So it's basically work with the data and the computing resources. Going a little bit deeper. So in the first, we divide our system into several layers. The first layer, this is like the authentication layer using the globals. It is naturally came in to the pictures because the funcX, they using globals as a tools for identifications. And then in the second layer, we have execution layer. When we develop different federated learning algorithm, we deploy the funcX client at the server, and at each site, each client, we will add the funcX endpoint at the machines and waiting for the jobs execution. So on the process will be controlled by the server, and we do the training on the local data, aggregating the information back to the server. So that is the big picture of what happens. And thanks to funcX, we don't need to care about what is the underlying computing infrastructure behind that. It can work naturally. We also have a communication layers when we use AWS S3 to communicate the models, because you know that sometimes when you want to train large models, it is not effectively to like serialize them and transfer them using funcX system. So we use S3 for communicating large files. So as a user, it is very easy to use, and I think the code is published. You can use this for your federated learning project when you have the data at multiple sites and you want to do some kind of learning across different places. And the users, you just only need to define a Python file that contains the models as a PyTorch. You need to define the data loaders as a regular Python scripts. You need to specify some simple client like the configuration, like the endpoint IDs, the data loaders that you use at each client, and of course, other files to control the federated learning algorithm. So putting all of this together, we can do some training, and this is just an example of the log where you can see that we can do the training at different sites, and the log can be integrated. With basically the learning jobs, everything is done as a funcX executors, and you can see that it is done very effectively. So few takeaways at the end, I want to emphasize that the ABFL, what we are developing here, is just an open source framework for privacy preserving federated learning tasks. And funcX turned out to be a very useful tool for us to effectively perform remote task execution without thinking too much about the underlying computing structures at the site. funcX authentication, naturally, using Globus can be extended. And this turned out to be a reliable ways for us to managing the data, computing, resources assessment, and cross-institution researches. So that is what we have developed so far. And we also always actively looking for collaboration. So if you have any new ideas you can think federated learning can be helpful in this sense, please feel free to reach out to us. Thank you so much for listening.
Awesome, thank you for that. Questions from the crowd, Nathaniel?
Yeah, so you mentioned differential privacy earlier in the slide. I'm just kind of curious, what are some future privacy preserving techniques for FL that you're going to explore with APPFL?
Yep, so actually, okay, so for the privacy preserving here, what we are trying to do is that we also developed our own privacy algorithm that can preserve the weight. Basically, when you're training your models, you have the weight. And if you apply some techniques to preserve the privacy, you basically cannot reconstruct back the original images or the data from the weight, which is like the gradient descent things, and you can get the weight of the models, and you cannot reconstruct the data back from that. I'm not an expertise on that, but we have several people in our teams are currently working on developing different algorithms that can make this process as much safe as possible. Yeah.
Thank you.
Yeah.
Any other questions? I think in general, I'm just really excited to see this work. It seems like such a natural combination of the work you guys have already done on the privacy preserving pieces, and being able to plug in the distributed computation part probably enables you to support a much wider range of use cases. So great to see. I mean, you did this without asking us anything about it, so that's also yeah, it's a very good sign that I guess it was usable.
Yeah.
Thank you very much. I look forward to finding out more about it and keeping up with what you guys are doing.